All right, so this is surface area of spheres, hemispheres, and composite figures. So we're going to start with the warm-up here, which is find the measure of each. It says find the radius of circle M if the diameter is 25. Remember, the radius is half of the diameter, so the radius would have to be 12.5 centimeters. The reason this is in the warm-up is sometimes that I'll give you the diameter, but you have to use radius. Next, it says find the exact circumference of a circle if the radius is 42.5 inches. So circumference formula is 2 pi r. And I gave you that the radius is 42.5. Remember, if you want exact, you're not putting pi in your calculator, so you have to do 2 times 42.5, which is 85. And then I didn't put pi in my calculator, so 85 pi. And then inches is my unit. Remember, circumference is a distance, so it's not inches squared. Next, it says find the exact area of a circle if the diameter is 26 feet. So I'm going to write down my area formula, pi r squared. So I have pi times, and then I need my radius squared. Diameter is 26, so that means that radius is half of that, 13 feet. Put in a 13 here. I want exact, so do not put pi in your calculator. 13 squared is 169 times pi, and then my unit is feet squared since it's area. Last part of the warm-up, it says the exact circumference of a circle. Find the exact circumference of circle N if the area is 625 pi centimeters squared. So I need exact circumference. I'm going to write down my circumference formula, 2 times pi times radius. So to find the circumference, I'm going to do 2 times pi, and then I need my radius. If you look, I did not give you radius. Instead, I gave you the area is 625 pi centimeters squared. So I'm going to write down my area formula. Area equals pi r squared. I know my area is 625 pi. So I'm going to do 625 pi equals pi r squared. And now I have to solve for r. Okay, so I need to get r by itself. Remember, this is multiplication here. So the first thing that I'm going to do is divide both sides by pi. These will cancel. So now I have 625 is equal to r squared. And now I can square root to solve. Remember, radii are positive, so I don't have to do plus or minus. And I get the radius is 25. Now I can plug in the 25 here, and I get the circumference is 2 times 25 is 50 pi, and then my unit is centimeters. Remember, once again, its circumference is a distance, so it's not centimeters squared. All right, that's it for the warm-up. So now we're going to move on to vocabulary. So we're going to talk about this shape right here, okay? This 3D image is called a sphere. A sphere is the set of all points in space that are a fixed distance from a fixed point called the center. Okay? So if I change just one word right here, space, to a blank is a set of all points, and I change that word to a flat surface, not necessarily space, then it'd be a circle, okay? Or in a plane is what I should say instead of flat surface. In a plane, that'd be a circle. Space is a square. I mean, a sphere, not a square. It says a blank connects the center of the sphere to any point on the sphere. So here's center of the sphere to any point on the sphere. That would be the radius. All right, next, a blank is half of a sphere. So if you look in this picture right here, the green is half of a sphere, which we call a hemisphere. And then last but not least, a blank divides a circle into 2 hemispheres. So they're talking about this shape right here, okay? And this is called a circle. If you cut a sphere in half, you'd get a circle on that flat surface. But if you cut it right through the middle, right through the diameter, it's going to be the biggest possible circle that would be made. So it's called a great circle, the biggest circle. If you took any cross section, it's just a circle. But right through the middle is the great circle. Okay, now we need the formula for the surface area of a sphere. So if we were all in person back in the day, we used to give every group an orange. And what they would do is that they would cut the orange in half, they would measure the radius, and then they would peel all the skin off of the orange. And they would make a few circles. I think I told them to make 5 to 10 circles with that radius. And then start peeling off the skin and put the skin inside each of those circles to see how many circles they would fill. So, moral of this story is that if you peeled the orange and you tried putting it in circles, it would end up being the area of 4 circles. So the formula for total surface area of a sphere is 4 pi r squared. So it's the circle formula, but there's 4 of them. All right. So this next one says here, find the exact surface area of a sphere with a diameter of 76 centimeters. So surface area of a sphere is T equals 4 pi r squared. T equals 4 times pi times my radius squared. So all that I need is radius to find surface area. I give the diameter 76, so the radius is half of that. Half of 76 is 38 centimeters. So I'm going to put 38 right here, and now I want the exact answer. So remember, I'm going to put everything in my calculator except for pi. I'm going to leave pi in my answer. Let me pull up my calculator here. So I'm going to do 4, and then parentheses 38, close it, squared. So that's, oops, that says 28, so that's not going to be right. Backspace, delete, 38. So notice that it automatically will square the 38 and multiply it by the 4, but you could also put a times right here if you want to be certain. You get 5,776. Remember, I'm not putting units yet because I didn't put pi in my calculator, so times pi. And then my unit is centimeters squared for surface area. Okay. All right, let's try the next one. Let's get this calculator. I'll just put it off to the side in case I need it again. Find the exact surface area of a sphere. So I need surface area of a sphere. I'm going to write down my formula even before I finish reading. 4 pi r squared. With a great circle that has an area of 49 pi. So total surface area is 4 times pi times the radius squared. I was not given the radius. Instead, I was given the area of a circle. Let me change colors here to highlight that. I was given area of the great circle. So area of a circle is pi r squared. I was given the area is 49 pi. And then equals pi r squared. So I have to solve for r. Remember, this is multiplication, so divide both sides by pi. These pi's will cancel. You're left with 49 equals r squared. Square root to solve. Remember, you don't have to do plus or minus because a radius is a positive distance length, so 7. So now I can put this in my calculator. I'm going to do 4 times, I know 7 squared is 49, so I'm going to do 4 times 49, and I get 196 pi, and then my unit is miles, so miles squared. Okay, let's move on to the next one. It says, what's the formula for the surface area of a hemisphere? All right, so let's think about this. Okay, so this right here is half of a sphere, right? It's like if I cut a sphere in half. So let's do half of a sphere. Half of a sphere, right? But if I just do the half of the sphere, it'll only cover that purple part. And I also have this other, ooh, I don't like that. I also have this other circle that I can touch. It's part of surface area. So I need to add the great circle to that. That is going to be my, the formula for a hemisphere. Couldn't think right there. So let's take half of a sphere. 4 pi r squared divided by 2, and then plus a circle, which is pi r squared. 4 divided by 2 is 2, so that's 2 pi r squared, plus this is 1 pi r squared, combine like terms, it's 3 pi r squared. So the total surface area of a hemisphere is 3 pi r squared. All right, find the exact surface area of the hemisphere. So hemisphere is 3 pi r squared. As you can imagine, the most common mistake people make is they do 2 pi r squared because they're like, oh, half. But don't forget about that circle on top that you can also touch. The radius is 15, so I need 3 times 225, and that is 675. So 675, I didn't put pi in my calculator, so times pi, and then my unit is meters, so meters squared. All right, let's move on to the next one. Find the surface area of a hemisphere whose great circle has an area of 100 pi inches squared. So surface area of a hemisphere, I'm going to do T equals 3 pi r squared. And then I just need the radius to find it. So 3 times pi times my radius squared, and I realized I wasn't given my radius. Instead, I was given the great circle's area. So area of a circle is pi r squared. I was given the area is 100 pi equals pi r squared. And I need to solve for r. So remember, this is multiplication. I'm going to divide both sides by pi. Both sets of pi's cancel. I have 100 equals r squared. Square root to solve, and I have r is 10 inches. So 10 inches, and then now I just need to do that. I can do this mentally. 10 squared is 100. 100 times 3 is 300, so 300 pi inches squared. Okay, the last thing that we're going to look at, if you look, we have 2 more left here. It's area of composite figures. So if you look at this first one right here, it says find the exact surface area of the composite figure. If you look, it looks like a cylinder with a hemisphere on top, okay? So we need to develop a formula of how we're going to get this. We need to develop a plan, okay? So I'm going to write down my plan first. I'm going to say what I see. Remember, the surface area is what you can touch. So first thing I notice is that I see a hemisphere, but I can't touch the circle on the hemisphere. So really, I'm going to think of it as half of the sphere, not as a hemisphere. Even though half of a sphere is a hemisphere, but I'm talking about what I can touch. I can't touch the great circle, so I'm not going to put hemisphere. And then I also have a cylinder that I see, but I can't touch all of the cylinder. I can't touch one of the bases. So I'm going to subtract one of the bases, which is a circle. So I'm going to subtract one of the bases, which is a circle. That's my plan. All right, so I'm going to start with this total surface area of half of the sphere. So please remember, you're not using 3 pi r squared because you can't touch this part right here. So it's just half of a sphere, which is 2 pi r squared. So let's do that. 2 times pi times the radius squared. The radius is this piece right here. If you look down here, the diameter is 12, so the radius is 6 inches. 2 times 36 is 72, so this is 72 pi. And then my unit is inches squared. All right, so far what I found is this. I got all this, okay? Now I need the cylinder, and I need to get rid of the circle. So I'm going to do the total surface area of the cylinder is equal to 2 pi RH plus 2 pi r squared. Now remember, you also have to subtract one of the bases. So I'm going to subtract one of the bases, which is pi r squared. So really, this is just pi r squared, sorry. So you have 2 pi RH plus 1 circle instead of 2 of them, pi r squared. That's the formula we're going to use. So we're going to do 2 times pi times my radius times my height plus pi times my radius squared. So notice there's not a 2 in front of that because there's not 2 bases. All right, my radius is 6 inches. The height of the cylinder is 9, and this is 6. All right, clean this up. 9 times 6 is 54. 54 times 2 is 108 pi. plus 36 pi. I'm going to do 108 plus 36 to keep pi in my answer. That's 144 pi. And that was inches squared. All right, so please realize that this is this work, and this is this work. So I'm going to follow along with my plan here, and I'm going to add those together. So I'm going to do 72 pi plus 144 pi. Now, if you're like, wait, why aren't you subtracting the circle? I already did that right here, right? I took care of it right here. Instead of having a 2 here, I got rid of it. 72 plus 144 is 216, if you want to double check, plus 144 is 216. Both of them have pi in them, so I can combine them to 216 pi, and then my unit is inches squared. And I'll put T for total surface area equals. Okay, let's move on to the last one. It says find the surface area of the toy chest round to the nearest tenth. Okay, we need to come up with the plan. Remember, it's everything we can touch. So on top right here, I see that that is half of a cylinder. Okay, and that's everything I can touch. I can't touch the bottom, so I don't have to worry about the bottom, but half of a cylinder. Now I also see that I have this prism right here, but I can't touch all of it. I can't touch the top of it, which is one of the bases. So I'm going to add the prism, but I'm going to subtract the rectangular base. All right, there's my plan. Let's see if we can do it. So I need total surface area of half of a cylinder. So I'm going to write this total surface area formula. I accidentally just put half instead of half of a cylinder. I'm going to write the formula for an entire cylinder and then divide it by 2. So an entire cylinder is 2 pi RH plus 2 pi R squared. So if I want half of that, I'll divide it by 2. Whenever you divide a binomial, which is separated by addition or subtraction, you have to divide both this and this by 2. So if I divide the first part by 2, 2 divided by 2 is 1 and it cancels, so I just get pi RH. Plus, and then if I divide this by 2, the 2's cancel and I get pi R squared. So for half the cylinder, I'm going to use pi RH plus pi R squared. So we're going to do pi times my radius times my height plus pi times my radius squared. All right, so I need my radius. So I need to know what is this length right here. If you look, this whole length is 12, so this has to be 6 inches. So my radius is 6 inches. I can plug that in here and here. Then I need the height of this cylinder, okay? So if you look, the cylinder is this long. That is 48 inches. Since they both have pi in them, I can get an exact answer. I'm going to do 6 times 48, which is 288 pi. Oops, I wrote 228. It's 288 pi. And then I have plus 6 squared is 36 pi. Then I can combine 288 and 36, since they both have pi in them, to 324 pi inches squared. That is the surface area of this cylinder, or the top of the treasure chest. All right, now I need the bottom, which is a prism. So I'm going to do total surface area, and this is going to be the prism, and then I'm going to end up subtracting the rectangle, but I'll do that in a different color. Okay, so prism is perimeter times height plus 2 bases. But remember, I am getting rid of one of the bases, which is a rectangle. So I'm going to get rid of one of the bases. So what I'm going to end up with is perimeter times height plus just one base, because I'm not using both bases. All right, so I need the perimeter times the height of the prism plus the base, the area of the base. So let's start with the perimeter of the base. I'm going to use green to trace this. So as you can see right here, It's not all the way through, but this is my base right here. Did a good job. The best I could do. So this is 48 and this is 12. So the perimeter is going to be 2 times 12 plus 2 times 48. I'll put that in my calculator. 2 times 12 plus 2 times 48. And I get the perimeter is 120 inches. And I can put that right here. All right, now I need the height of the prism. The height of the prism is this, which is 22 inches. And last but not least, I need the area of the base. So area of the base is base times height, 12 times 48, or 48 times 12, same thing. 12 times 48, and I get 576 inches squared. So 576 here. This is going to give me the total surface area of the prism minus the rectangle. So 120 times 22 plus 576, and that gives me 3,216, is it inches? Yes, inches squared. Okay, so all that's left to do is to add the cylinder part to the prism part. So I have to do 324 pi plus 3,216. Notice that pi is not in this answer, so I cannot combine them and get an exact answer. That's why the directions say round to the nearest tenth. So I'm going to type this in my calculator, 324 pi plus 3,216. Now I can round this as my final answer to the nearest tenth. 4,233 point. It's an 8 on the calculator, but there's a 7 next to that, so that's 9. And then my unit, once again, is inches squared. Okay, that's it for surface area of spheres, hemispheres, and